So today we are going to be talking about a problem called the zigzag problem. I was browsing through YouTube and someone was saying there, like they have tried to understand it several times, but still they are unable to. So they say the string people is hiring is written in zigzag pattern on a given number of rows like this. I think this is the first issue with this problem, which is it's very hard to visualize. What they mean is you want to actually put the letters following a pattern like this one. You start with P, then you put A, then you put Y, then you go over here and you put P again, then A, then L, then I, etc., etc., etc. They want us to go in horizontal lines. So P, A, H, N, etc., etc. Let's draw only the part that repeats itself, which is this. You start somewhere, and then you have some length here, which I'm going to call rows. Uh, and then you have again this diagonal pattern. And then you just repeat that more times as needed until you actually run out of all the letters and then you are done. One thing that we can see straight away is that for any given letter, so suppose the first letter, in this case P, if I want to traverse in this direction, one way that I could do it is traverse this string, but instead of going one by one, I could jump over some of the letters. So I could take P, so that's the first letter of the output, so that's good. And then I could jump over A, Y, P, and land on A. And then I would take A and jump over L, I, S, and take H. And then again jump over three other letters and go to N. So you can see there's a pattern here of jumping over the same number of letters. So if we go to the second line, so we took just those first ones, which are essentially take a letter, jump three letters, take the next letter, etc., up to N. However, when we get here and we take A, for example, we actually jump over one letter and take P and jump again over one letter and take L. So the number of letters that we actually jump over changes depending on the position that we are in this figure here. You can see there is essentially two separate parts to this figure. So the first part is this bit here. So let's call that A. And then we have the second bit here, P. If you are in some point here, the next point that you actually want to capture is the point that is on the same line here. So that's always going to be this plus this. If you're on some point here, then it's a different thing. You actually want to jump over this plus this. And if we take the prompt here, let's put this in here, and let's actually define a new function, unfold maybe. And then you're going to take several parameters here. So I think the string itself may be position, the number of rows. Let's capture the depth because you're going to go with a recursive solution. So if we know the depth and we know the length of the output string, essentially we know when to stop the recursion. And let's actually have something called row start. I'll explain that one later. And then we need to define the types here. So that's going to be exact, non-negative integer. That's that. Then string. Then same thing again for position, rows, and row start. So let's think about the simplest case. So if we have a single row, the zigzag pattern is going to be the same thing as not having a zigzag pattern. If the number of rows is 1, then we just return a string. I'm actually going to call it input instead of string. So the second easy case is if the depth equals string length of the input. So essentially, if we have recursed enough times that our output string is now the same length of the input string, then we just return empty string in this case. So if we are given a position here, then we could, from that position and from the number of rows, we could figure out the position of the start and end points. Now, for doing that, we need to know how many letters are in each one of those triangles here. So in one triangle, this piece here, you are going to have rows, letters here, and this should also have rows letters. However, if you think about it, you are counting twice here and twice here and here. So y is both part of the vertical line and the diagonal line. And A and B are in the same position if you think of it as a sequence of equal triangles. This is going to be 2 times the number of rows, but minus 2 because you're counting 2 letters twice. Cool. We can use let here to define some variables. We just divide the position by, let's call this the period, and then multiply again by the period. So I can define period here and use it down here. Cool. 2 times the amount of rows. However, we want to actually subtract 2 from that value. So end position we can think of as the same thing as the start position, however, plus an extra period. Now we need to think about what do we do in each case of the problem. You can either be here or you can be here. It's going to be start plus this size here, which is rows. If it's higher or equal than start plus rows, then it's part of 2, otherwise it's part of 1. And we put an if statement here that's essentially going to say the position is higher than start plus rows. That's actually, there must be a first character, so let's define that. I will call this, I'll just call it beginning, because it's the beginning of the output string. That's going to be essentially the character that's in the position referenced by position here. So, but converted to string. So we could do a string ref. String ref is just getting whatever is in a string in that position. Okay. And now we can actually use string append that beginning string plus something else, which is just going to be calling float again for the next triangle problem. So the next little zigzag that we have there. And fold takes that. It takes the input, it takes the position. However, the position here is going to be the end position of this problem plus, so let's define a new variable for that. Let's call that distance maybe. So distance is going to be the remainder of position divided by rows. Cool. So that's the segment distance, and then segment end distance is just rows minus segment start distance. Is that correct? So if we have the distance here being 0, 1, then the other distance should also be 1. So that should be 3 minus 1. So we have to do the same thing here. Subtract 1. Let's use this other notation. Cool. Cool, cool. Awesome. This position here is going to be the segment and distance plus the end. Cool. And then what else do we have? Rows and rows start. Cool. And then we have the second case, string friend beginning code depth input, and then so we are somewhere inside here, and we want to know the next place that we cross, which is going to be here. So it's essentially the same idea. We have this end distance here, and we are going to sum it with this bit here. So that's the segment start and not the segment end. Actually, like before we had this point here, right? And now we also have this other point. However, we don't have this point here, which is this point plus rows minus 1. So we know to start, we need to sum that with rows minus 1, and then sum that with the segment start distance. So that's going to be start with rows minus 1, and also summed with segment and start distance, and then rows and row start. Cool, that's most of the problem. Now we need to think about another small thing, which is the position could happen to be higher than the actual length of the string. So that's why I have a row start here. That's going to represent which row we are in right now. And depending on if we have crossed over the last character in this string, then we are going to move that to the next row. So we are going to define row start if position is greater than or equal to the string length as the input. Of the input. In this case, we are going to return +1 row start. Otherwise, just plain old row start. Cool. And now we can also redefine position to be same thing. In this case, position is going to be the row start position because you're starting over from the next row. Otherwise, it's going to simply be position. Cool. And what else do we need here? Oh, actually, what we need to do is increase the depth. So increase depth. I think that should do it, actually. So let's just call this new function called fold. And we want to fold depth 0. The input, let's call this input rows. Position 0, rows start at 0. And that should do it. This condition should have triggered start because it's rows -1. Okay, so now it's correct.